What's up? It's Christopherson, and this is my train project. Some of the goals for this project include programming the train to run on each part of the track, using an HMI to choose the train's path, and using various sensors to locate where the train is. Now I'll cover my project plan. This first page just shows off a quick description of this project as well as my plan. Next, I'll go on and show my conceptual drawings. I've made a drawing of both the top and bottom level. This next tab is my parts list. This has the parts that I use as long as some specifications. This next tab contains of my input devices. Here are my output devices. They are separated by VAC and VDC. Here is my timers that I use in my program. Here is the bill of materials with a link to the part, and the total is just under $40,000. Here's a quick little list of my materials with my wires and terminals. Finally, this is the spreadsheet that I use to track where every single wire is terminated. This made it easier for me to understand where the wires are and what devices they are leading out to. Alright, here's my wiring diagram that I created. I'm going to begin by covering the 120 side. This is 120 AC coming off of a disconnect. This is going into a 4-plug receptacle. It's also going into the tube lights that are lighting up the bottom level. This also feeds the Slick 500 and my 24 volt DC power supply. That power supply then powers the safety relay, the PoE switch, and the panel view. Also feeding off of 120 is the 24 volt AC transformer, which feeds the track switches. Also feeding off of 120 is both of the transformers for the train tracks. Depending on which control relays are on will depend on if the train tracks will run in forward, reverse, or fast and slow. Now I'll move on and show the safety relay. This is standard safety relay with the dual contact e-stop and a push button to reset it. This safety relay is going to be used to cut power from both of the output cards. This will be able to stop any output devices from being activated. Now I'll move on to the input card. On the top here is my first set of sensors. Only the receivers are going to the inputs and the senders are just getting powered. Down here is the next set of sensors. These are wired the same, they're just a little different brand. Now moving on, here are the elevator proximity sensors and how they're wired. Then below them are all the limit switches. Some are normally open, some are normally closed. And here the final input is used for safety. Now moving on to the first output card. This is AC. This is where all of the track switches are, and they're all wired the exact same. And moving on to the other output card, this one runs on 24 volts DC. It's got all the control relays. And it's got a solenoid, the banner, panel light, and the stack light, which has got different colors, and the horn. And finally, here's how the motor is getting controlled. This is being controlled by 2 relays. Now I'll cover the operation for this project. To begin, you're going to want to log into one of the 3 users. For this demonstration, I'm going to log into Supervisor, as I'll have access to everything. More information about the users can be found in the user manual. Once you log in, you'll have access to 3 displays: the train display, alarms page, and monitoring page, each of which will be able to get back to the home by clicking the home button. To begin, I'm going to click Route 1 and click Start. This will start the train on running Route 1. The train will begin in the home base, and Route 1 will run on the outside track. Once it hits the elevator, you can see on the monitoring page that the horn will sound, and you'll also be able to monitor everything else. Now once we run on the bottom, we'll run in reverse, and we will also run the outside since we're still on Route 1. Now, once the train drives back into the elevator and the elevator will move, you'll be able to see the horn sounds again. In the monitoring page, you can view all of this. The train will now drive back into the home base and will be ready to run another route. This time I'll run Route 2, which will run the inside track. You can also see that in the train display on the top right corner, you can see the stack light. This is the same stack light that is used in the monitoring page and can be used if the physical stack light is not visible. The train display also shows all of the track switches and their current positions. These are labeled by either an A or B depending on which side is currently active. And finally, the train display also shows which route is running, how fast the train is running, which direction it is going, and if the elevator is moving up or down. Now, once the route is completed, the train will drive back into the home base. Now I'll simulate stopping. The train can be stopped at any time by pressing the stop button. After pressing the stop button, you must press the start button to make the train run again. You will also be able to change the train's route by clicking the other route that is not selected. You won't be able to change the route in all locations due to changing the route causing a derail. To stop this, the route buttons will disappear once you are in an area where changing the route will cause a derail. Once the start button is pressed, it is programmed so that the train must complete one full trip before going to the elevator. Now I'll demonstrate stopping the train on the bottom. You will also be able to choose a different route while the train is on the bottom. Changing the route on the bottom will also change its return path once it reaches the top again. Now I'll simulate an e-stop. Now I've clicked the e-stop button and the pop-up will show and the train will stop in its position. You'll be able to close this pop-up and then go view this alarm in the alarms page. Here you can acknowledge it, acknowledge all, or clear all. Once an e-stop has happened, the operator must take the train off of the tracks. If the elevator is at the bottom, the elevator must first be manually brought back to the top by using the two buttons in the monitoring page. Then the train must be returned back to the home base, and then you can start once again. More information about this project and how it operates can be found in the user manual. Feel free to pause and look at this manual if you want to read more about how this operates and what each of the displays contain and what they do. The final page of this manual consists of the IP cameras and their logins. Here is a view of the top camera. This can just be accessed through its web page. Both of the cameras are PoE. Here is the bottom camera, and it too can be accessed just by typing its IP into the search bar. And here is a network map consisting of all my devices and their IPs. Now I will cover my programs. This is my RS Logix 500 program. This is communicating with my SLC 505 in my cabinet. This program is used just for messaging, as it allows the compact Logix in our classroom to read the SLC's inputs and write to the SLC's outputs. Now I'll cover my program made in Studio 5000. This first routine consists of the messaging between the SLC and the compact Logix. It also contains the jump to other subroutines and other logic that is used just for bits that are used within the HMI. This next routine is the route control routine. This consists of the logic of selecting a route and starting that route. This also consists of the timers that turn on the track switches for only a short amount of time. This next one is the track control routine. This is all of the logic for running the tracks in fast or slow or forward and reverse. The next routine is all of the logic for the elevator. This logic relies heavily on a counter that counts how many times the train has gone into the elevator, and by using that count we can tell where the elevator is and what should be going. The final subroutine for this project is all of the tracks outputs and also all of the HMI bits for telling which track is currently activated. And here is my summary. If you want to read what I thought went well and what I thought needed improvement, you can pause and take a look. If not, that's all. Goodbye.